Hi viewers, you're welcome back. Now let's attend to question number 40. In the diagram, P, Q, R, and S are points on the circle with center O. Angle QRS equals 5x. Angle QOX equals 6x plus 24 degree. Find angle QPS. Now we are looking for angle QPS. So this is the angle we are looking for here. We have to look for this color of the angle. Now to get the angle QPS, when we look at this diagram, this will remind us some theorems in circle geometry. Now, we are looking at this. Let's first look for the value of x, because we don't know the value of this x here. So to get the value of this x, let's try to solve that out. We observe that arc SPQ, that is this major arc, subtends this angle 5s at the circumference. So arc SPQ subtends angle 5x at circumference, and also this minor arc SRQ, that's this minor arc subtends this angle QPS, this angle circumference as well. So then recall from circle geometry that the value of the angle subtends at the circumference is equal to half of the angle the same arc subtends at the center. So now this major arc SPQ at the center, this is angle that it subtends at the center, this angle here, and we don't know its value. So recall that this angle at a point, so when we add this all together, it must give us 360. So the value of this angle here is going to be, sum of angle at a point is 360. That will be this angle here minus 360. Then we can write QOS, that's QOS, angle QOS plus 6x plus 24 is equals to 360. And angle QOS is equals to 360 minus 6x plus 24. That's this the angle at the center of this major arc SPQ. Now, if we've gotten the angle at the center, recall that I said a theorem says that the angle it subtends at the circumference is half of the angle it subtends at the center. Now, if it has this at the center and this at circumference, it means arc SPQ subtends 5s at circumference, and this is the angle at the center, and 360 minus 6x plus 24 at center, and 360 minus 6x plus 24 at center. So hence we're going to have the angle at circumference, which is 5x, is equal to half of the angle at the center. That will be 360 minus, minus 6x plus 24. And we simplify this. Then from here, we can put this over 1 so as to cross multiply, so that these two can come up with this 5x. So 2 times 5x, that's 10x, is equals to, then that's 360, open the brackets, this is minus, this should be in bracket like this. So minus times 6x, this is minus 6x, minus times 24, this is minus 24. So 360 minus 24, and this minus 6x coming over here, then we're going to have 10x plus 6x is equals to 360 minus 24. And 360 minus 24, that should give us 338. So 10x plus 6x, that should give us 16x is equals to 360 minus that's 336. Yeah, that's 336. Then from here we're looking for x. Divide through by 16 by 16. So this here one. So x equals 336 divided by 16. Let's see. 16 goes there 1. 16 goes into 33. That should be 2. Yeah. 2. Remember that 1. Put the 1 here. 16 goes in 16. That's 1. So x equals 21. Now we have gotten the value of x to be 21. Now recall, we're looking for this angle QPS. That's the value of this angle. And I said that minor arc SRQ subtends angle QPS at circumference. So hence angle QPX is equals to the half of what it has at the center. So here it has this angle at center. This angle is at the center. 6x plus 24 at center. And angle QPS at circumference. That will be the QPS is equals to half of the angle at center, which is 6x plus 24. 6x plus 24. Now we got the value of x to be 21. So just to put angle QPX is equals to half times 6 times 21 plus 24. And 6 times 21. Let's see. 6 times 21. 6 times 20 is 120. That's 126. So then we have half times 126 plus 24. 126 plus 24 actually give us 150. So then we have half times 150, and half times 150 that should give us 75 degrees. So angle QPS is equals to 75 degrees. And from the option here, we have option A as the correct option. Thank you for watching. Bye.